Hey everybody, welcome back to my next video lesson. This one we're going to take a look at ions and see if we can predict the charge based on the position of the ion on the periodic table. Now we've already talked about ions in the last chapter a little bit, and a couple of these vocabulary words are going to seem familiar to you because we've already written them down in our notes from the previous chapter. First of all, what is an ion? If atoms are neutral particles, ions are atoms that have gained or lost an electron to become a charged particle. And contrary to what you might think, ions oftentimes are more stable chemically than atoms are in their natural state. So atoms will try and pick up electrons or lose electrons in order to become more stable. Now when an atom loses electrons, it becomes a positive charge, because a negative charged electron being lost, subtract a negative equals a positive. Now typically these elements are metals. The metals are the left side of the periodic table in the middle, and a little bit under that stair step known as the transition between the nonmetals and the metals known as the metalloids. Now anions, on the other hand, are when atoms gain electrons to become more negative charged, because you're adding negative, that means you're becoming more negative. And these are typically nonmetals. So most of the time, these elements are found in the upper right-hand corner of the periodic table, as you see down here. The periodic table is organized by element, and in some cases we can predict the charge. Not all cases, but some cases we can predict the charge of the elements based on where they are on the periodic table. Now you might have gotten a general idea of this in a previous science class, but we're going to get a little bit more specific because this is honors chemistry and we ask a little bit more out of you than maybe you did in 9th grade or science classes even in middle school. Let's begin looking at the periodic table over here in the first group. These are known as the alkali metals, and they all have a +1 charge and only a +1 charge. There's one exception, and that would be hydrogen up here. Hydrogen, depending on how it's bonding, could be a +1, usually it is, but it could also be a -1 charge ion. Moving over to the second group, we've got the +2 charges. These are the alkaline earth metals. See, these elements have 2 valence electrons, and they don't want those 2 valence electrons. They are unstable when having 2, so they want to get rid of them so that they open up the p6 orbital underneath them. And when they do that, they all get a +2 charge. Now we're going to skip the transition metals for now because they have unpredictable ions. They're all positive ions, and that's important because they're all metals, and metals typically form positive ions. But they have unpredictable. In fact, some of these transition metals can have 2, 3, or 4 possible different ionization states. So let's go over here to this group. This is group 13, and the top of the group is boron. Boron will be a +3 charge, and so will the element underneath it, aluminum. But once we get down into here, just like the transition metals which we just talked about, these elements could have a possible +1 or a +3 charge in terms of their ionization. We'll talk about that here in a second. Now in previous science classes, you might have been told that this column, which is group 14, which is led off by carbon, as a +4 or a -4. But to be honest, carbon never forms ions. It uses covalent bonding rather than ionic bonding. So we don't even mention this in honors chemistry. Carbon and silicon don't form ions. But underneath the metalloid stairs, you'll start to see ionization forming for elements below that. Again, we'll talk about the various reasons why they form 2 ions here in a little bit. Now we get to nitrogen and oxygen and fluorine, and these elements all carry a -3, -2, and -1 charge respectively. And of course the noble gases, because they have a full p6 orbital, or in helium's case s2 orbital, they don't gain or lose electrons, and they are completely happy with a charge of 0. The reason these elements have negative charges is because they have 5 valence electrons, 6 valence electrons, and 7 valence electrons respectively, and they're more likely to gain an electron in order to achieve that p6 electron configuration. And so nitrogen is a p3, it will gain 3 electrons to become a p6, whereas oxygen is a p4 and it will gain 2, and fluorine is a p5 and it will gain 1. And you can treat all elements underneath those similarly. Now let's discuss these elements which are under this bold stair-step line and talk about why they have 2 possible ionization states. This element right here is gallium. gallium's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 3p1. Now, if you take into account what we learned about last chapter, when we say that when it comes to ionizing metals, they lose their electrons from the highest energy level first. Well, we have a 4s2 and a 4p1, so you've got two orbitals that have a 4 in front of them. So let's follow our rules, which we learned about last chapter, and we start removing electrons from the 4th energy level before we start taking them from this 3d orbital, which we talked about, which is sandwiched in between the 4s2 and the 3p1. Well, if gallium loses its first electron, it's going to lose it from the highest orbital in this case, which is 4p, because p is higher in energy than s, so let's lose this electron from the 4p. If it does that, then you can see how it becomes a +1 charge because it's lost 1 electron. But now think about this. What if it starts to lose more electrons? Well, there are 2 electrons in this 4s orbital, 4 being the highest energy level, remaining, because there's a 3d after it, but we don't remove electrons from the 3rd energy level if there's a 4th energy level available. So let's remove these 2 from the gallium's 4s orbital, and now it's lost 3 total electrons, and it could have a +3 charge. So in some cases, it'll lose 1 electron, lose that p electron. In some cases, it'll lose the s electrons in order to have a second ionization state, which is 3+ or +3. Now the same can be applied to these elements underneath carbon and silicon. This is germanium, and it has 2 electrons in the p orbital and 2 electrons in the s orbital, and the same sort of situation applies. The first 2 electrons we'll lose will come from the 4p2, and then the next 2 electrons it loses from the 4s2, leaving the 3d untouched. And the same is true with this element right here. This is antimony. It could be a +3 or a +5, and that trend follows all the way down to the bottom of those groups. So hopefully you know a little bit more about how ions form when it comes to elements' position on the periodic table. That takes care of this video lesson. Thanks for watching.